Hi folks, it's Conandrum again. This video is called The Nature of Light at Long Ranges, and I'm going to describe how I decoded information from the Bowditch Naval Manual. My goal is to show you that what we think we know about light is mostly because of theory and not because of direct empirical data gathered. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. It is a quotation from Nikola Tesla, in my opinion, the greatest scientist that ever lived. To Tesla, the theory of relativity of Einstein was just a mass of error and deceptive ideas violently opposed to the teachings of great men of science of the past and even to common sense. The theory wraps all these errors and fallacies and clothes them in magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying error. The theory is like a beggar clothed in purple, whom ignorant people take for a king. Its exponents are very brilliant men, and they are metaphysicists rather than scientists. Writing a decade before the explosion of the atom bomb and ignoring the space curvature data from 1919 eclipse, which supported Einstein's idea that space was curved around large bodies such as stars, Tesla suggested that the existence of a force field would account for the same mathematical results. Thus Tesla brazenly concluded not a single one of the relativity propositions has been proved. Yes, Tesla did not think much of Einstein. And I don't think much of Einstein either. Just because a theory comes up to explain something doesn't make it true. There may be many other explanations for what we see. Just because Einstein's theory was promoted to be popular and has become the status quo today, doesn't mean that it is the truth. I will follow this with a quote by J.W. Reid entitled The Life of a Photon. As noted earlier, it tries to travel in a straight line. He's talking about the photon. So the photon is trying to travel in a straight line, but it cannot quite succeed. Stars affect its path, clusters and even galaxies pull it off its course. Stranger still is that even after these effects are taken into account, it still curves slightly. The mass of the entire universe affects its trajectory. Space itself is curved, and our particle follows this curve. In the 2 million light years it travels in its life, this curve is a subtle influence, but is real. Astronomers would very much like to know the exact shape of this curve, the curve of light. Positive as on a sphere, or negative as on a saddle-shaped surface. The photon knows, but it isn't telling. So we see this quotation by J.W. Reid is greatly influenced by the general theory of relativity. You see, theory is beginning to seep into reality, is becoming reality, and we're basing all our observations on a theory before it's even proven correct. So what we see here is that we have been influenced by this theory and are supposing that light, like a river, follows the curvature of the land to the sea. We're supposing here that light is going to follow a curvature of space to some place. We're supposing that light is going to curve to the curvature of space. Nobody has ever measured the curvature of light. Nobody even knows the curvature of space. This is a page from astronomy.ohiostate.edu. So this is a university, and Professor Barbara Ryden here in 2003, she is stating that we don't know exactly how curved space is according to Einstein. So what is the curvature on a large scale? It must be one of the three possibilities, but which? In 2003 she didn't know. If space is flat, the universe is flat, or positive as in a sphere, or negative as in a saddle, or the inside of a sphere. So she doesn't know. In 2003 she didn't know. I don't know if she knows today, but what I'm gonna say is that today, in 2015, the results of the Planck mission showed the cosmological curvature parameter to be this number, which is coincident with a flat universe. So the universe that we observe, because if it's a sphere like the Earth, if the universe is a sphere and we're living in a small section of it, there is a horizon and we can't see the rest of it. So they're supposing that the area where we live in the universe, the observable universe, is flat, but it still could be a flat part of a big sphere, or a flat part of a saddle, or the inside of a sphere. So we don't know much, and we're assuming a lot. And we're assuming that light is traveling on the surface and that it's slightly bending. But how much? We don't know, guys. We don't know. And all this is based on a theory. Yes, all this is based on a theory. Using this notion, discuss the observation consequences of general relativity. Light bends due to the curvature of space. Light will take a path of least time instead of least distance. So, general relativity has greatly affected how we think, and we're now blending reality with theory. This is cuckoo land. We're entering cuckoo land. This was Einstein's first answer before he fully developed the general theory of relativity. Later, he gave a deeper explanation that light bends when it travels in space-time geometry that is bent. We shall see later in this chapter that the presence of mass results in the bending or warping of space-time. The mass of Earth is too small to appreciably warp the surrounding space-time, which is practically flat, so any such bending of light in our immediate environment is not ordinarily detected. So light bends around large objects like the sun, that's what they think. And so, yes, the light ray from your laser will technically be bent by the Earth's gravity, but no, the effect will not be enough to be noticeable. So there is an effect, they believe, from Earth's gravity on light, but it is not noticeable, and actually, they think that if a beam of light were to pass right over the Earth's surface, it would be bent by 0.0006 arc seconds, which is infinitesimal, compared to the Sun, which would bend it by 1.75 arc seconds, which is a noticeable amount.
Is there anything that says that that photons or that light follows the curvature of the Earth, like that gravity affects it in some way. I don't know. I haven't looked into that. I probably should. But if the Earth is a sphere and if photons follow like a gravitational path, maybe that'll explain why things don't disappear on the horizon. That's just pure. I don't know if there's any real science behind that. That's just me thinking out loud. But have you come across anything like that?
Yeah, plenty of my detractors are talking about the bending light theory. And I'm going, well, that's convenient. What if it's a flat Earth and the light's just bending so you can't see the hull of the ship?
Yeah.
I'll play the card against you. I'm going to flip the board on you. I don't know. I mean, if we can't trust light to tell our eyes what's going on, then there's no way we can visually confirm anything if that's true. Because if you're always about the magic bending light trick, I mean, how do we trust anything that we see?
Right.
I don't think you can. So then, at that point, if we can't confirm anything that we see, and people want to disregard the test that I'm trying to perform, then we're left to trusting NASA. And frankly, I don't trust them. And you say, well, other people have gone out there, and the Japanese. I'm like, really, watch the stuff that others have put out too. It's just as bad. Now, have I seen every single video and every single photo ever put out there? No, of course not. But of the ones that I have, not just the United States, I've seen European stuff put out. I've seen stuff put out by the Japanese. It's all just, in my mind, just as bogus and easy to debunk as the NASA stuff is.
So yes, can we trust our eyes? Can we? So this image is of course imaginary. It's fake. And this is how we have been deceived. This image was taken from Navigation by Lighthouses, a video showing night piloting from 1943 US Navy. The story and the example are real, but the image used is for primary school. If you believe in Santa Claus, then you can believe in it. This guy lives on a perfect circle. Light in his world is straight. In his fairy tale world, he can with a 100% accuracy calculate how far away his horizon really is, using this formula. This is a real formula for a perfect circle distance to horizon. It's based on Pythagoras' theorem. It's real. You can use it on a perfect circle and you can find the horizon. But we must be able to separate fact from fiction or fact from theory. We must teach our children how to do this. Reality is different to theory. Is our world a perfect circle? Is our light straight? Can we apply this formula to our world? Let's see. This is Nathaniel Bowditch. Nathaniel Bowditch was an early American mathematician, remembered for his work on ocean navigation. He is often credited as the founder of modern maritime navigation. Nathaniel Bowditch lived between 1773 and 1838. He was a self-educated American mathematician and astronomer, author of the best American book on navigation of his time. In my previous video, Lighthouses Destroy Flat Earth Theory and Global Sphere Model, I went into some depth regarding this example mentioned in the video Navigation by Lighthouses. In this video, I will go into further depth explaining exactly how light behaves in the example. So in the video, we have this diagram explaining the situation. However, if we apply these numbers on a perfect sphere with perfectly straight light, we have huge discrepancies. Are the distances mentioned in the video straight line of sight distances? Is this distance 15.4 miles in a straight line of sight from the horizon? And is this 8.5 mile distance in a straight line from the horizon? As we can see, the Pythagoras theorem has a huge discrepancy of 3.21 kilometers. The numbers do not add up. So the next logical assumption would be, are the distances mentioned distances on the water surface? Again, we have a 3.21 kilometer discrepancy. Using these formulas, where the distance mentioned in the video is not actually a line of sight, but it is a distance measured on the surface of the sphere, we can see that still we have a big discrepancy of 3.21 kilometers. Nothing has changed. So what's the next logical assumption on how to explain things? Only curved light can explain the observations. The distances are, in fact, on the surface of a sphere, but the heights are not how they are shown. The heights are 180 feet, but the light must bend towards the horizon and bend away from the horizon in order to explain the numbers. Now, the Pythagorean theorem is okay and there's no discrepancy when you accept the fact that light is bending both ways in order for the numbers to work. So only curved light can explain the observation. Only curved light and curved distances on a sphere. There is no straight line in this example. There are no straight lines. So Pythagoras is not wrong. It is our perception of how light travels that is wrong, and we have to fix that. So this image that you see here is imaginary. It is fake. This is how you have been deceived. Intentionally or unintentionally, it doesn't make a difference. We're still deceived. Whether there's a conspiracy or not, that doesn't change any facts. The fact is, we have been deceived. The story and the example are real, but the image used is for primary school children. Are we going to move on? Or are we going to stay here in Kukuland? Now, Bowditch, in his 2002 values, in his manual, shows that light bends even more today than previously thought. You see here, for 180 feet of elevation, in 1943, he stated a 15.4 nautical mile distance. In 2002, he's stating a 15.7 nautical mile distance, as a 0.3 mile difference. And also, for the same example, we see that in 1943, he stated an 8.5 nautical mile distance for a 55 feet elevation, whereas in 2002 he's stating an 8.7 nautical mile distance. So, what's going on? Bowditch, since 1943, has revised the distance to the horizon upwards. Why would the Navy do this if we know everything there is to know about light? Is the Navy still learning how light really behaves? And what are the consequences? If we know everything, then why are we still adjusting our formula? I searched online for experiments done in vacuum involving light curvature and I found nothing. Even in today's space age, we pretend to know light, but in reality we know very little. Just recently it was discovered that light can be slowed down and that light does not travel as fast as previously thought in the vacuum of space. Who knows what we will discover next? The truth is that we have no proof whatsoever that light travels in a straight line in a vacuum and at long distances of tens or hundreds of kilometers. We have no proof. We have therefore devised our formulae on light based on what little we know about it and how it behaves down here on Earth, starting with the wild assumption that light travels in straight lines. So whatever deviation we experience from its imaginary straight line at long distances, we immediately explain it away as caused by the atmosphere. Atmospheric refraction has become a garbage bin in which science discards every deviation in order to explain the observation. Without knowing how light behaves at long distances in vacuum, science will continue to make wild assumptions, and our formulae will continue to be wild approximations which are valid only in our petri dish. So you can sleep well at night, everything is explained. So the false assumptions of science are for the purposes of practicality. I would do exactly the same. I mean, I'm not going to wait until I discover what shape the Earth is before I ride a bicycle. I'm not going to wait to understand everything before I do something. Understanding or not the shape of things doesn't stop me from living. So today, any deviation from the theoretical straight line is immediately discarded into the garbage bin called atmospheric refraction. Any deviation. Yeah, the bin has unlimited capacity. In the future, though, we may come to accept that light is naturally bending by itself to some degree, and that we have previously been fooled to attribute so much of this bending to atmospheric refraction. We will then split our current formulae into two parts. One part is the bending due to the natural curvature of light, and the second part is the bending due to the real effect of atmospheric refraction. There may be two effects acting upon light. Here the percentages, of course, are just for illustration. I don't know how much is natural bending, I don't know how much is atmospheric bending. We don't know. But until we test our theory about the straightness of light with real experiments carried out in the vacuum of space at tens or hundreds of kilometers distance, we will never know the truth. Until such time, we have to realize, though, you and me here watching this video have to realize that our formulae are theoretical. They're crude and based on a wild assumption that light is perfectly straight. Yes, we have to assume that in order to make any kind of measurement. We're assuming that it's going in a straight line, and then we're correcting to fit the observation. This is from the Bowditch Naval Manual. It's telling you here, in various places, that we are really assuming that light is straight. It's an assumption. It's an assumption. It's telling you here that a standard is a value of quantity established by custom, agreement, or authority as a basis for comparisons. So light traveling linearly has become a standard. It has become a custom and an agreement. And the goal of all this is practicality, because it says here that there's another almanac. The Air Almanac uses a different formula than the Bowditch Manual, and is intended for air navigation, but the differences are of no significance in practical navigation. There are differences, but the goal is practicality. The goal is to navigate, the goal is to fly. The goal is not to measure the exact curvature of light. The goal is to navigate. The goal is to target something. That's the goal. We don't care about the curvature of light. We just care if it's going to reach us or not. That's what matters. The Navy, that's what matters to the Air Force. It's telling you also that when refraction is normal, objects appear slightly elevated and the visible horizon is further from the observer than it otherwise would be. Since the effects are uniformly progressive, they are not apparent to the observer. So everything that we see is a result of refraction, but because refraction is uniformly progressive, we do not notice it. So visible reality is because of uniform refraction, uniformly progressive refraction. It's a mirage. So the truth is that we do not know light. We're just predicting where light should go. In the same way, we are predicting the weather. The Navy has devised and revised their formula based on observation. There are also other formulas, of course, based on the same principle, where the square distance from the horizon is multiplied by a factor to answer various questions. Now, my advice is, do not fall in love with your formula. Your formula does not describe light. It is not a universal law. It is merely trying desperately to predict its moves, and many times will fail miserably for reasons you may be beginning to comprehend now. Just as the Navy has revised their formula, you can rest assured that your formula will not stay the same forever. Here I have to tell you that I have placed a certain amount of trust in the Bowditch manual formula, not because I think it's the truth, but because I know it is used daily for life critical applications such as navigation in the oceans, etc. This places it at the top of my list until more accurate data arises. So, if you understand these facts, that the Navy, always based on observation, has shown that light bends in an arc. This is the arc, the actual arc. This is the true light path that I plotted on a graph, okay, based on the Bowditch Naval Manual formula. So, yes, the Navy has shown that light bends in an arc and that there is something called the horizon, which is a physical obstruction. The Navy proves on a daily basis that when two horizons meet, you can easily see much further than you thought. If any of you are proponents of the flat earth theory and understand these facts as I explained them, you have to try and find a replacement for the flat earth theory. Perspective and vanishing point are not the whole story. It's a bit more complicated than that. So if you want to know more, click here to watch my other video, Lighthouses Destroy Flat Earth Theory and Global Sphere Model. Now let's continue. Is there any straight light anywhere? Let's investigate this. Let's look at theory versus reality. Theory says there's a theoretical horizon, but reality says light travels beyond the theoretical horizon to a true horizon, which is further. Now we explain this two-way of bending of light, from the lighthouse to the horizon, and from the horizon to the eye of the observer, as being caused by atmospheric refraction. Now, there is, between the two theoretical horizons, a dead zone. Based on the curvature of the Earth, or of the circle, we have to understand that no straight light can originate from this dead zone, because it's beyond your theoretical, geometric horizon. Only bent light can originate from the dead zone. In our example, the dead zone is 4 kilometers wide on the surface of the sphere. Keep this in mind. So, straight light can only originate in these sections. So I made a graph, and on this graph I plotted distance in kilometers against elevation. The x-axis is at the 1 kilometer increment, while the y-axis is at a 2 meter increment. So our lighthouse is approximately 26 meters high, and I plotted on this graph the curve of the Earth in blue. This is to scale, by the way, and I plotted different Bowditch light curves in different colors, indicating a different light curve for a different horizon. So, taking the horizon at 20 kilometers as a first example, 20 kilometers away from the horizon, light would reach a height of 26 meters. Accordingly, the blue line is a line that joins the horizon at 12.4 kilometers with an elevated position of 10 meters at the lighthouse, and so on and so forth. So you can see from this diagram that light bends uniformly and progressively from the horizon or from the lighthouse to the horizon, vice versa. How then can somebody be convinced that light just a few meters away from the horizon will not travel in a similarly curved manner? How can I convince somebody that light just a few meters away from the horizon is gonna reach him in a straight line? I don't see any logic in that. I just see bent light in every single situation and even between these curves. You can see that there's a multitude of horizons for each elevation at your location. As you move higher, you're going to be subject to light coming from a different horizon, and all of these lines are curved. So how do you think light will travel in between these lines? Do you think light is going to travel in a straight line in any situation? I don't think so. I think light is subject to bending in all situations. And this is a similar case. Do you think light is going to travel in a straight line, or is it going to bend slightly, accordingly, similarly to the light curve that is coming from the horizon? Of course, there's going to be a bending. So the conclusion is that all light curves always. There is no such thing as straight light. It's just a theoretical construct that is helping us navigate, that is helping us in all practical applications in our daily lives. And we can see it even in books. Astronomy for the layman, reality before belief. In this book, the author states that for all practical purposes, he will use line of sight or straight travel for light in the following chapters. He's not going to pretend to know the curvature of light. He's going to assume straight light for practical purposes. It's the same diagram, but we've now zoomed in to the 1 kilometer section. Here, the light paths look perfectly straight, but they're actually bent. No wonder then that we're continuously reminded that light is straight. 99% of all measurements we take are for our everyday intents and purposes. We're not usually concerned with anything further than a few hundred meters away from us. Even surveyors are not usually concerned with distances more than a few hundred meters away. Even they are very rarely asked to perform measurements of a few thousands of meters, for example when building a football stadium or a golf course or a road section, and even then these measurements are done in small sections. This is the limit of human observation and measurement today. In these rare occasions is when the limit of human tools such as theodolites tested, and much correction has to take place in the measurements based on theoretical and rough generic formulae on atmospheric refraction. So there's no such thing as straight light. This is a truly global representation of how light curves at millions of horizons everywhere. Is there any room left for straight light? Is the same example that as we've seen with the lighthouse and the ships. You can see the lighthouse and the ships and where each ship is being impacted by the light. So all this light from all these horizons, it shows you that there's no room for straight light. Light is bending everywhere. Here's a closer look. Of course, it is to scale. However, the lighthouse in the example is 291 kilometers tall. Light is bending everywhere in the atmosphere. These are the horizons. The horizon for each different elevation. This next section is called the insistence of vision. Why did I call it that? Because just like in a mirage, your eye will insist on placing images in front of you in a straight line, no matter how the light reached your eye. Your eye doesn't know where the photons came from, if they came in straight or if they came in curved. So your eye insists on placing images in a straight line in front of you. This is why mirages happen. In a similar fashion, if we were, say, at 145 kilometers above the surface of the Earth, light from the horizon would reach our eyes in a curve. But our eyes will insist on placing the horizon in a straight line in front of us, at a tangent to the curve of the real light path. And everything in between our eyes and the horizon will of course be lifted up. As Bodic states, the effects are uniformly progressive and they are not apparent to the observer. But for those who still have some doubts on whether straight light exists, let's assume that straight light is reaching us from this blue section and curved light is reaching us from the dead zone. So curved light only from the dead zone and straight light from everywhere else. In this case, let's assume that we're at a 10-meter elevation here and we're looking at the horizon. Our horizon is 12.4 kilometers away. Our theoretical horizon is 1128 kilometers away. Curved light reaches us from the horizon. Straight light is reaching us from the theoretical horizon onwards. In this case, what would we see? We would see an apparent ramp from the theoretical horizon onwards. We would be seeing ships going away from us towards the horizon, and then we would see them climbing up a ramp towards the sunset. This apparent ramp would be covering the last 10% of the distance towards the horizon. It would be 1.12 kilometers in length. But is this what we observe? Do you see a permanent tsunami near the sunset? No, I don't think so. It's a uniform optical ground lift-up from our eye all the way to the horizon. the real horizon. So we have a theoretical horizon and we have a true horizon. And everything in between the true horizon, the theoretical horizon, and the place where we're standing, everything, it seems, uniformly elevated. There is no straight light. There's only bent light, all the way from the horizon to our position. I recommend this website if you want to get the best explanation on atmospheric refraction at sunset. In figure 1, it says, this figure here, if the Earth had no atmosphere, the daylight circle, the boundary between day and night, would divide the Earth exactly in half. Okay? But sunlight entering Earth's atmosphere is refracted as it passes through the atmosphere on its way to the surface of the Earth. Near the horizon at B, where sunlight strikes the atmosphere at a low angle and must travel through significantly more air to reach Earth's surface, atmospheric refraction can raise the actual position of an object on the horizon to an apparent position half a degree or more above the horizon. So it appears half a degree above it. It appears. So this is a visual optical horizon, is an apparent horizon. It's not the true horizon. It's half a degree above the real horizon. And this effect moves the daylight circle into the night, effectively causing slightly more than one half of Earth to be illuminated. So refraction reaches in the dark area of the Earth. What we see around us is an illusion. It's a mirage. Everything appears flatter to the eye around us as a result of curved light. The horizon rises up virtually, optically, apparently, to meet the tangent of the photons entering our eye. Our eyes insist on flattening the Earth. The eye has no idea where the photons originated and therefore forms an image in the brain based on the photon's angle of impact on the retina. The horizon and everything in between is a mirage. Think about this for a minute. Imagine we create a 10-kilometer pipeline from cheap PVC piping after we dip it in black paint to avoid reflections. Imagine we glue a switched-on laser light in one end and then seal it. We seal the other end with a glass seal so we can see the light when it arrives. Imagine we lay it out on supports and then we vacuum it with a vacuum pump. We then adjust it here and there until the light shines through. The other side. The resulting shape of the pipe would be the actual curvature of light, especially if we adjust the temperature so there's no refraction in the pipe. So when you actually lay your eyes on this shape, the shape of light, whatever curvature it may have, what would you call it? Would you call it straight? What would compel you to call it straight? What are your reasons? Would you call the Guinness Book of Records to take a photo of the straightest line in the world? How would you even know if it is straight or not? What do you have to compare it to? Why would you call it a straight line? How would you know if it's a straight line or not? Now let's say that you are sent on a mission on an unknown planet. You're left on the planet They tell you that there's no atmosphere, the planet is of an unknown shape, and your mission is to discover what shape it is. And they give you three options. They tell you that it's either a sphere, the outer side of a sphere, or the inner surface of a sphere, or that it's a flat plane. They give you three options. There's a 100-kilometer lake where you have landed, with perfectly level standing water, with no tides and no external influences. You're given 3 boats with 3 flags of the same height, and you're given a theodolite. How would you determine the shape of this place? 1. Having no atmosphere, we do not have to account for refraction anymore, which is nice. Your eyes will align the flags based on the photons that already landed on your retina, without knowing where these came from with any certainty. So you will place your theodolite in front of the flags, you will align them and see if there's any difference. Now the theodolite, or total station, will be directed by your eyes along this alignment to take measurements. The light train your eye chooses for any alignment will ultimately be the basis for your conclusion. So your decision will be based on a light train. Your decision will be based on what your eye chooses as the alignment. So what do you think? Is this light train straight as an arrow now that we do not have an atmosphere? Without this knowledge, all your tools are useless. If you are going to use a ruler to draw a straight line, you better make sure it is straight. So if you're using light to make an alignment, what gives you the impression that it is a straight line? You can only make comparisons, not alignments, with light. So this is the mirage as seen through the eyes of a child, which is us, humanity. And a conundrum is now beginning to unfold. The theodolite is a very accurate piece of machinery, but ultimately it is your eye that has the last word. When you're looking through a theodolite and you target any object, for example the horizon in this case, what path do you think the light train is following? Now think before you answer it. Where are the photons coming from? How sure are you as to the real and true path of the photons that just hit your retina? Did they originate from above or below the water level at your position? Did they originate from above or below your horizon? And can you prove it? Is our Earth flattening upwards or is it flattening downwards? Where did that photon come from, really? Of course you cannot answer this question. Optical equipment, in the same way as the eye, are designed to study the photons after they arrive. They are mirage measuring tools. Unfortunately, photons do not come stamped with an origin address. How do we know where the photons are coming from? Why are we correcting downwards and we're not correcting upwards? There's only one reason. The reason you're correcting downwards to the curvature of the Earth is because theory says that the Earth is a sphere. That's why you're correcting downwards. There's no reason why you shouldn't be correcting upwards. And I'm telling you, prove it. Prove to me that the photons that are coming to your theodolite and into your eye, prove to me that they're not coming from a concave curve. There's two paths that can create the same angle of impact on your retina. Just in case you did not understand the conundrum, the virtual horizon, which we see every day, is the tangent of the light train coming from the real physical horizon, creating a virtual optical horizon, an apparent horizon. So if the photons are coming from below, our Earth is flattening up. If the photons are coming from above, our Earth is flattening down, creating the same virtual optical horizon. So which is it? Is our Earth flattening up, or is it flattening down? The result will be the same. How do you know which is which? How can you prove one or the other? We're choosing this option because of theory. We're not choosing this option because it's not popular, but it could be the truth. Horizon declination. The curved light paths and the models, in the different models. When I eventually found a way to plot all voltage light curves against their respective ground, I noticed there are quite different shapes and peculiarities. I thought it would probably be a piece of cake to distinguish between them, based on each curve's tangent. But I was so wrong. They're so very different, but unfortunately, when you plot the horizon declination angles, the tangents of each curve, when I plot the tangent of each curve at each position, I cannot distinguish between Earth models just using the declination angles, which is very weird. There is a slight difference between them, but it's only noticeable at very high elevations and very long distances away from the horizon. So you need to be at least 200 kilometers away from the horizon at a 2.4 kilometer elevation to notice just a 0.005 degree difference. You see, the flat model with curved light stands out with a 0.04 degree difference. It is almost as if we were not meant to perceive any difference. I get the feeling that we were meant to just perceive the world as flat as possible, but with limitations to how far we can see, in order to keep us wanting to explore it, just like in a strategy game. Caveat emptor. A picture is worth 1,000 words, and that's about it. That's why it will never be a complete picture. A painting will forever capture the brush strokes of the painter. We can see and testify that the strokes are all there. What we do not know is exactly how each stroke was placed, what colors were mixed, which strokes went first, what was the motivation, the intuition and the drive behind it. Who was the painter, and when did he paint it? It is capturing the moment, but not the essence of the moment. It's just an image of the moment. It's not the reality of the moment. We can only speculate on how it was created, because the mechanics, the flavor, the smell of the moment, they're all missing. A whole other side of this image is actually missing. Just how exactly did the paint end up on the canvas? Do we know? Can we speculate? Assumptions can lead to false conclusions. And of course, does it matter? Does it matter if we assume wrong? Well, it is bad news for people who spend millions on art. You have to understand that people who spend millions on art have a great danger if they speculate wrong as to the origin of the art they're buying. The Andy Warhol Foundation was the authenticator, the actual authentication board, the official arbiter certifying artwork. And they dissolved because they certified artwork that was discovered or alleged to be fake, and they couldn't bear the legal costs. So authentication provides scholarship and a measure of security for an owner, and without it, few, including the major auction houses, will touch a piece of art. So the authentication of art is a big business. One expert is too afraid to reach out to a museum that is exhibiting a work he believes to be inauthentic because he fears legal retribution. So authenticity is a big problem. And without an authentication board, the door has opened to more forgeries floating around the market. Every day there's more stories about fakes. The legendary Manhattan Gallery, Knoedler & Co., closed in 2011 and was sued 3 years later after accusations that it sold a number of previously unknown works that were actually knockoffs. So authentication is a difficult business. Even the authentication boards and all these experts that are professionals and it's their job to authenticate paintings, many times can make mistakes. Legislation is very watered down, says Walks, and while it may hinder spurious lawsuits, it will not solve the problem by any means. In other words, when it comes to art and authentication of art, it is always caveat emptor. It's a Latin term that means let the buyer beware. Similar to the phrase sold as is. This term means that the buyer assumes the risk that the product may fail to meet expectations or have defects. In other words, the principle of caveat emptor serves as a warning that buyers have no recourse with the seller if the product does not meet their expectations. Just how exactly did the light end up in my eye? Does it matter? The term is actually part of a longer term, which means let a purchaser beware, for he ought not to be ignorant of the nature of the property which he is buying from another party. The assumption is that buyers will inspect and otherwise ensure that they are confident with the integrity of the product before completing a transaction. Did you do your own due diligence? Or are you blindly relying on authentication boards and official arbiters to certify and assure you of the origin and authenticity of the images you are seeing? If you are, then beware what you're buying into. You are personally responsible. You must be careful not to turn into a cult follower, making the agency your church and your religion. You have been warned. Don't worship images and idols. Is it straight or is it bent? Who knows? Straight light suits the status quo. If they announce light bending to you, everything, including the heliocentric model of the solar system, goes out the window. Check out my video, Calculate the Distance to the Sun. So take personal responsibility and admit to yourselves that the official arbiter could be wrong or even just remaining silent. Take power back into your own hands. There is a solution. When in doubt, check under the hood. Conclusion. This is why I do not see how theodolites and other optical tools will ever be able to answer the question whether our Earth is a convex sphere or a concave sphere. Only the rectilinear experiment can answer this question, because it is not game to the winds of light. It is a different approach. It's not optical. It's a mechanical and rigid ruler, and the only truly reliable method. And thanks to Stephen Christ for making this known. Otherwise, I wouldn't know about this. So many trillions are going into the so-called space exploration, and not one dime has been spent for a cheap and simple but monumental experiment. By now, we should have found out exactly how light bends and what the shape of the Earth is, and we should have had an International Rectilinear Day to celebrate and replicate the experiment in every university in the world. If you do not have serious doubts by now, then no worries. I do not expect everyone to understand this video. I would encourage the interested among you to do a Kickstarter rectilinear project and invite universities to attend and take part. Your deception and indoctrination starts when you step foot in school for many reasons. It could be intentional, it could be unintentional. It doesn't really matter if you're deceived. Maybe the author could not be bothered to draw a curved line. Maybe the author thinks it's easier for you to understand it with straight lines. For example, teaching children. The author maybe is instructed to only use straight lines. All of the above are patronizing and unnecessary and have led to much confusion. And I rebuke all the above excuses and I accuse their authors of deception. Because when showing images like this, maybe they should emphasize the fact that the lines are imaginary. Yeah, maybe parents should also emphasize to their children when talking about Santa Claus that he is also imaginary. That's what I would do. So there can be only one. These are the three versions of our Earth. It could be flat, it could be convex, it could be concave. It doesn't matter what you like. What matters is reality. It could be any one of these. This is, of course, without refraction. With the refraction, everything looks like this. This is what we see today. This is the real picture. This is what we see today. We see everything flat. But it's either this or this. Of course, I have to close with a quote from the Bible. And God said, "Let there be light," and there was light. And God saw the light, that it was good. And it really is good. It creates everything around us for the pleasure of our eyes.